Resource management. A tour of C++, concurrency and utilities. When you wish to instruct, be brief. Cicero. Introduction. From an end-user's perspective, the ideal standard library would provide components directly supporting essentially every need. For a given application domain, a huge commercial library can come close to that ideal. However, that is not what the C++ standard library is trying to do. A manageable, universally available library cannot be everything to everybody. Instead, the C++ standard library aims to provide components that are useful to most people in most application areas. That is, it aims to serve the intersection of all needs rather than their union. In addition, support for a few widely important application areas, such as mathematical computation and text manipulation, have crept in. One of the key tasks of any non-trivial program is to manage resources. A resource is something that must be acquired and later, explicitly or implicitly, released. Examples are memory, locks, sockets, thread handles, and file handles. For a long-running program, failing to release a resource in a timely manner, a leak, can cause serious performance degradation and possibly even a miserable crash. Even for short programs, a leak can become an embarrassment, say by a resource shortage increasing the runtime by orders of magnitude. The standard library components are designed not to leak resources. To do this, they rely on the basic language support for resource management using constructor/destructor pairs to ensure that a resource doesn't outlive an object responsible for it. The use of a constructor/destructor pair in Vector to manage the lifetime of its elements is an example, and all standard library containers are implemented in similar ways. Importantly, this approach interacts correctly with error handling using exceptions. For example, the technique is used for the standard library lock classes. Mutex M, used to protect access to shared data. Void F. Unique lock mutex LCK M, acquire the mutex M. Manipulate shared data. A thread will not proceed until LCK's constructor has acquired its mutex M. The corresponding destructor releases the resource. So, in this example, unique lock's destructor releases the mutex when the thread of control leaves F through a return, by falling off the end of the function, or through an exception throw. This is an application of the resource acquisition is initialization technique, RAII. This technique is fundamental to the idiomatic handling of resources in C++. Containers, such as vector and map, string, and iostream manage their resources, such as file handles and buffers, similarly. Thank you for watching.